Hello guys, Tony here, Explore Crypto channel, and in today's video we will go back into the console and I will show you how to do Base58 encoding. I'll try to explain it in very simple terms so everybody can understand it, even if you are not a programmer, not a developer. So yeah, it will be super basic video, so if you got the knowledge about Base58, you don't even have to watch it. It's very short, and I did it because in the next video I will be speaking about BIP32, Bitcoin Improvement Proposal 32, about the HD wallets, and basically this Base58 formatting is needed there, so I just decided let's do the separate video. So yeah, that's the video. If the sound quality is bad, sorry for that. Today is super windy day here in Vancouver, and I just don't have any more time to record it, so it has to be today or never. So yeah, I'm just going back to my console and I will show you guys how to do it right now. But before the console, let's try understanding some concepts about Base58. I will be speaking today about Base58 encoding, not the checksum, because there is also Base58 checksum that can be applied to addresses and things like that. Today I will be speaking strictly about encoding. So what is Base58 encoding? Basically there are different number formats, you can have binary format, decimal formats, hexadecimal formats. Of course, binary format has 0, 1, decimal numbers from 0 to 9, hexadecimal has 0 to 9 plus A to F letters. Base58 is different, and it derived from Base64, which was used to add additional payload to the emails in forms of this encoded string. So Base64 is 26 uppercase letters from A to Z uppercase, 26 letters lowercase from A to Z, 10 numbers 0 to 9, and plus and slash. Basically, Base58 is the version of Base64 specially crafted for Bitcoin. Satoshi crafted it for Bitcoin, and it doesn't use 0, it doesn't use capital O, it doesn't use capital I and lowercase l. Also, it doesn't use plus and slash, so it has 6 characters less. That's why it's Base58, not 64. So yeah, we've got 58 characters in this specific encoding, and I crafted this specific example. So for my example, for my code, we will use this hexadecimal number 4D61. So if we convert it to decimal, 61 is 97 and 4D is 77. How to convert the whole hexadecimal into integer, because in this particular example in my code I will be using integers, it will be easier. So first we've got the first hexadecimal, it's 61, so basically it's 97, because that's double digit in hexadecimal, it's 97. You can convert it in any converter and it will return you 97. How is that? Because 1 times 0 and 6 times 16, if you add it together, it's 96 plus 1, it's 97. Yeah, we've got the number. Okay, 4D is 77. 4 times 16 is 64. Plus D is 13, so it's 77. Yeah, but we can't multiply it by 1, but we have to multiply it by 16 times 16, because it's another character in hexadecimal. So 256 is 16 times 16. So 77 times 256 gives us 19,712. If we add it together, 97 plus 19,712, we've got this number 19,809, which is our result. So 4D61 is 19,809 in decimal. I won't be converting it to binary because in this particular case in my code we are using integers just for clarity. Everybody knows integers, it's easy to understand. So if we would have another number here, we would have to multiply the result of this number by 256 times 256. So that would be like another number here, and we would have to times 256 times 256 and get the result if we want to add another number in front of this like original hex. But for this specific case we will go simple, and that's the result, 19,809. And yeah, if we have this number, now we want to convert it to our base 58. So converting it to base 58 is basically few iterations. Every iteration is the same. So we have to divide it, but divide it in terms of integers without the rest. So 19,809 divided by 58 is 341, and the rest is 31. So the modulo is 31. So it's 341 comma like around 5,5, something like that. We want the floor of this number. So 341, this is what like this division is doing. In my code I will use like specific division operator, but that's for later. And the second operation, basically this division operator will do all those two things simultaneously, but the second operator is modulo. So we want to divide this number 19,809 by 58, and like what's the rest? If that's the whole number, what's the rest from the division? That's the rest. So 31 left from this full number division. And yeah, basically we take this 31, we look at the base 58 alphabet. Here is our alphabet, and assuming we are starting iterating from 1 as 1, we have to add another number 1 to have 32 and go to 32nd letter, which is Y. In our code, we don't have to do this plus 1 because the machine code iterates from 0. So 1 is index 0. So we just have to take the index 31st index, and that will be Y. That's just something that I just wanted to explain. So yeah, from the first iteration when we divided it by 58 and we've got 341, now we take the 341 into second iteration. So we know Y is the first letter. Let's take iteration 2, and basically let's put this 341 into second iteration. So yeah, we are taking this 341, we are dividing it by 58 without the float number after the comma, and the result is 5. If we would divide it with the comma, it would be like 5.8, 5.9, because the rest from the division is 51. Out of 58, it's like 0.8, 0.9. The second operation, modulo, so we are taking 341 modulo 58, and the result is 51. So our letter will be 51st, assuming that we are starting from index 0, or 51st plus 1 if we assume that we are starting from 1, and that's small letter t. Now, we divided it by 58, the result is 5. Okay, let's take 5 divided by 58. Obviously it's 0, because without the float it's basically 0. 5 doesn't divide by 58, and yeah, 5 modulo 58 is 5. The rest from the division is 5, it doesn't divide. So 5 plus 1 is 6. Let's look at the sixth letter, sixth number. It's 6. If we start from 0, it's like, let's take the 5th index, and it's also 6. So the result is YT6, but in terms of base 58, we have to reverse it. The end result is 6TY because the string has to be like reversed. So the end is at the beginning and things like that. So that's the encoding. This is how you can encode the number, the letters, or some like numbers in binary into base 58. Now let's go and try to code it. So I'm in my PyCharm empty project, and let's start from just defining the function that we will be using. So define B58 encode, and it will take some string v, okay, and we have to define alphabet because that's like super important for this case. Like this alphabet that I was showing on the on this infographic, it has to be defined by you, and this alphabet can be found on like Wikipedia in some code instructions. It's very popular to just, it's super easy to find base 58 alphabet, so just Google it and it doesn't rather change. There are some versions of base 58 for different use cases, but Bitcoin base 58 alphabet is always the same. Okay, so what we want to do is print our v first. So print ski, that's the library that I have to import. So ski, okay, the library is imported. Now we just want to print our string that we trying to encode. So the next step, okay, let's maybe try if it works. So test equals ski dot unhexlify, because we want it to be in binary for the 6.1. Okay, and print B58 encode test. Okay, that should be it. Now let's try to run it. So as we can see, it's binary for the 61 and probably none because it doesn't return anything. So yeah, we've got this print. Let's go back to the function, and what we want to do is create our first variables. So level and number. So I will explain in a second what's the level and what's the number. So let's try doing the first iteration. So now we want to get this for D61 and create this big integer out of it, this 19,809. This is what we are looking for. So for character in reverse v, let's print character first, so I will explain. So print new line character is format, because we want to print the character and the character. Yep, so let's save it. in reversed, not reverse, reversed. Okay, so as we can see, what it does, it prints two characters, 97 and 77. So 61 is 97 and 461 is 97 and 4D is 77. So reversed basically takes the last, starts from like last character and goes from last to first versus iterating through like normal characters, so from 4D, 61 and etc. So reverse basically in loop 4 takes the last characters and make them first ones. So basically it reverses the direction of the string. So we can start creating some integer out of it. So our number will be like our this end integer. So our number equals number, so for now it's 0, so plus equal is like the operator that takes number and adds something to that. So it's 0, so basically it's 0 plus level, and our current level is 1 times character. So character, the first one, is 97. So first number will be 97, basic, like we had in this infographic here, 97. And let's print it. So print number equals dot format number. Okay, let's try it. So yeah, character 97, number 97. For the second one, character 77, number 174. It shouldn't be this way because like our number here was 19,712. So we have to do this multiplication times 256. Let's do it. So next line, and level equals level. It basically shifts bits 8 to the left side. That makes every number 256 times bigger, so it's 2 to the 8. So it's like 2 to the power of 8 is 256, and this is what we are doing. This is like the smart way of doing that in code. So our level is every time after every iteration we are making it 256 times higher. So also let's print the level just to see how it looks like. So level dot format level. Okay, let's print it. Okay, first character 97, number 97, because it's like the whole number is 0 plus 97. The level is 256 after it. So it's like for the next iteration it's 256. So the next character 4D is 77, number is 256 times 77 plus 97, and that's the result. If we would have another iteration, the level would be 65,536. So for the next one, if we would have it, but we don't because we only have 2 hexadecimal characters, that's our next level. So we have to multiply the next character by this number and add it to the current number. So yeah, this is how the encoding into integer works. So now let's build a string out of it. Let's do this division modulo and start building the string. So our string, I will just declare it here. It's just empty for now. I would have to declare it as I did. So while number, so it's basically if number is bigger than 0, if number is bigger than 0, then do x. If not, stop the loop. This is what this while is doing. What we want to do is just print 2 new lines to divide this part of code from the rest. And now let's do number modulo equals div mode number 58. What it does, as I said, we will have this smart way of doing integer division plus returning modulo in like one comment. We wouldn't have to do we wouldn't have to do number equals number divided by 58 and modulo equals number modulo 58. This function basically makes it like it returns number and modulo in like one tuple. So let's use it versus using these 2 comments because it's cleaner. And the string, because we already like that would be our result for the first iteration. We would have the number and we would have modulo. Looking at our infographic, the number would be 341 and modulo would be 31. So yeah, let's try to do the string out of it. So string equals our alphabet indexed by the number, by the modulo, sorry, and add the string, because as I said, we want to like reverse the return characters. So if we got like ABC from it, like if the first iteration is A, we want the A to be before, like after B and after C. So it would be CBA at the end. So this is what the adding string at the end doing. Basically, we start building this string, but we add to the beginning of the string every time. Like we add to the beginning and then append the string to the rest. So yep, that's our string. So now print new line number modulo and string. That format number modulo string, and after this while loop we want to return our string. So now we are returning it, so we won't have this none as the return, because now we will have some value that we are returning, and it will print using this part of code, print encode of test. So yeah, that's our first loop. I already explained it. This is how we build our integers, and that's the second part of the loop. So let's look. I will just move this console a bit and let's look closer. So we are printing two new lines. Cool. Like here are the two new lines. Then we will print two new lines here again. But yeah, number is 341 because 19,809 divided by 58 is 341 without the rest. The modulo of it is 31, so divided with the rest is 31. The string is y. Second loop, we take 341 as a number, so we had this number modulo. Now we take the previous number, so 341. We are doing division by 58. The result is 5. Modulo is 51. So the string is t. We are adding this t to y. So the result is ty. And yeah, we are moving to the next loop. So we are taking the previous number was 5. So we are doing div mode 5 and 58. So the number is 0 because it doesn't divide. The modulo is 5. So the string is alphabet from modulo. So alphabet from 5. The letter is 6. So 6 plus ty is 60y. And the result, the end result that we are returning here, return string and printing B58 encode test, is 60y. So I hope that was pretty easy and pretty well written in the code to understand it. I hope at least. And there are multiple implementations of Base58 encoding. Like you can do it in binary, you can do it on integers as I did. You can do it in some sort of hexadecimal, but not really. Like there are different ways of encoding it, and like the result is always the same. And you also can encode like the text. You can encode binary numbers. You can encode text. Because like text can be transformed through ASCII to hexadecimal, and then from hexadecimal, as we did, we can just encode it into B58, so Base58. And yeah, I think that's pretty common use in Bitcoin. You could like a lot of like the private keys, public keys are encoded Base58. Addresses are Base58 with some checksum. There's a lot of this kind of encoding in Bitcoin, because like this is human readable. So if you want to translate the string to the paper in some way, like back it up manually just by eyeballing it and writing it down on the piece of paper on the second computer or something like that, just for security. You don't want to use these like specific letters like 0, O, I and small letter L, things like that, because it makes this process complicated. So that's why Base58 is the improvement to Base64 for Bitcoin specific use case. And yeah, I hope I explained it well. If not, please write the comments down below and ask some questions, because I'm here to help. I'm here to educate. And yeah, I hope this video was clear enough. And yes, see you in the next video. Probably if in this series Python for Bitcoin, I'll be speaking about BIP32, so how to do HD wallets from your seed. We did the seed in our first video in this series, BIP39, how to derive the seed out of some entropy that we created, how to do the mnemonic out of it. So the next video will be expansion to this video, so how to generate our private keys, how to generate the public keys, and how to do the whole keychain of these keys. That's for the next video. So today I was just going to explain this one function, Base58, because it's used in encoding in like BIP32 to encode into these private keys, public keys. That's why this video is today. So yeah, thanks for watching. If you like this video, please hit the like button. Subscribe to my channel if you are looking for the content like that, because obviously I'm making it and I will be making more videos like this one. And yeah, have a great day and see you later. Bye.